how did the universe turn from a small, finite point into an infinite thing? How come the observable universe is 93 billion light years across, when the universe is only around 13.8 billion years old? How does infinity expand? Those are some of the questions we'll be looking at today, so let's get started. First things first, what is the observable universe? Well, it's the part of the universe that we can observe. Who would have thought? Now, what that means is that since the universe is only around 13.8 billion years old, light only has had 13.8 billion years to travel through space. And nothing travels faster than light. So, if we follow simple logic, shouldn't the observable universe be only 27.6 billion years across? Well, yes, it should, if the universe was static. But it isn't. It's expanding. Of course, we don't actually see light from tens of billions of light years away. We see light from galaxies that are 13 billion light years away. And knowing the expansion rate of the universe, we can measure its current location. And that's how our observable universe ended up being 93 billion light years across. But how do we know the universe is expanding? Well, the answer is redshift. When the source of light is moving away from you, the wavelength of the light increases, which makes the visible light look redder. The opposite of this is blue shift, in which the source is moving towards you, making the visible light appear blue. So, all you have to do is look at other galaxies. Astronomers did this, and they found out that not only are galaxies moving away from us, but the farther they are from us, the faster they move. In fact, galaxies are racing away from us faster than the speed of light. But how is that possible if nothing can go faster than the speed of light? Well, that's because the galaxies themselves aren't moving away from us. Instead, new space is being created between the galaxies all the time. So, the distance between galaxies is increasing faster than the speed of light, but the galaxies themselves aren't moving that fast. And that pretty much answers the next question as well. How does infinity expand? The distance between 2 points increases. That's all there is to it. Yes, I know, a little bit disappointing. But let's talk about the Big Bang for a second. Here's a common explanation of the Big Bang. In the beginning, the universe was infinitely small and infinitely dense. Then something, or someone, triggered the Big Bang, and the universe started expanding and cooling down. Now that begs the obvious question. If the universe is now infinite in size, how was it infinitely small during the Big Bang? When did it become infinitely big? Is there a certain point when something goes from finite to infinite? Well, the answer is rather surprising. The universe has always been infinite in size, even during the Big Bang. You see, it wasn't the universe that was infinitely small at the time. It was our observable universe that was. The rest of the universe was infinite in size and infinitely dense, and the Big Bang happened everywhere at the same time. To make it easier to think about this, forget the idea of explosion. The Big Bang wasn't an explosion in the vacuum of space that somehow spawned the entire universe. Instead, it was an infinite universe, with everything packed so tight, the density was infinite. Time didn't exist, so it's impossible to say how long it was in that state. And don't even bother asking why everything was there in the first place. We don't know, and we never will. But then, for some reason, the universe started expanding. The distance between 2 points started increasing with incredible speed. Time started running. And that's what we call the Big Bang. But do we really know the universe is infinite? What evidence do we have? Well, the answer is that we don't know. It could very much be finite. But the reason why scientists seem to favour infinite universe is because of the curvature of the universe. To put it briefly, the curvature of the universe can be either positive, negative, or zero. Our observations from our observable universe seems to point towards zero curvature. In other words, we assume our universe is flat, or at least close to being flat. Now, Einstein's general relativity implies that a flat universe is infinite. And that really is the simplest way you can put it. As you can see, we really don't know if it is infinite. I mean, our observable universe could be all there is. Or maybe it's a tiny part of the universe, so tiny that it appears flat to us, even though it's curved on a large scale. We will probably talk more about the shape and size of the universe in the future. And speaking of the future, if you want to know what the future of our universe looks like, you should check out the previous video. And the rest of you, thank you very much for watching. Make sure to subscribe to not miss any future videos.